Hi, I'm Jeff Morris. I'm Vice President of Product and Solutions Marketing here at Couchbase. And I want to talk about one of the core value propositions of Couchbase Capella. And that is its low TCO, as demonstrated through a variety of performance benchmarks that we've run or we've commissioned to have run throughout the course of 2020 and 2021. So as I walk us through this, what I'm really going to end up doing is we'll talk about first some of the recent performance improvements that we found inside of Couchbase Capella and Couchbase Server 7, right, which is really the engine that drives Capella here. Then we'll talk about the Yahoo cloud serving benchmarks and their results, how we set up the, how we set the tests, as well as how we are performing and identifying the different calculations we're using to create a metric that I'll call the cost per billion operations per cluster. And you'll see that that's really the core TCO number that we want to be talking about. And then we'll wrap up with what this really means for you as perhaps a new Capella user. So Couchbase Capella, which we announced earlier this week, is a brand new modern cloud database as a service. It comes in two flavors. A fully hosted and managed flavor by Couchbase, as well as an in-VPC option where you can deploy it in your cloud and you control all of the infrastructure, et cetera. But what's really cool about Capella is it is as easy as SQL. And when we say that, we say it's really going to be familiar to you. It's got the familiar schema structures. We call them scopes and collections, but it's still that dynamic data containment model that a schema often represents. We've added ACID transactions in our query language directly. We have a number of SQL constructs that you're really familiar with, including joins, and one of the tests that we're going to run includes join activities in it, and you can see how Couchbase performs against some of its competitors. We have UDFs, we have cost-based optimizer, we have parallel indexing. That's a brand new capability that made indexing builds dramatically faster than what they were before. And this is added to the flexibility of Couchbase 7, including the flexibility of having a JSON structure as your core document format. All the multi-model services like key value access, these full text search and analytics services that you have for rounding out your application as you're building it. And then the independent data query processing capabilities like the data service, the query service, indexing, all the backup service is brand new. All of these are actually what's driving Couchbase at the back end. Our SDKs, and then of course the performance and scale of Capella in the cloud. And that's what we really want to end up talking about here today. Deploy it wherever you need. It does include, some of its offerings includes cross data center replication, cross cloud replication. And you're going to find it's really fast. It's support, if you're familiar with Couchbase Server at all, you'll find that rebalancing is better. We have a much reduced memory footprint, as well as our CPU consumption is far more optimized. So there's a whole lot of elements here that are going to make Couchbase Capella really scream. And that's what's driving our total cost of ownership value proposition there. So, of course, remember, single database, multi-model in data access style. So so many options from a single data store. You get in-memory performance. You get the flexibility of JSON. You get the compatible structures to relational systems. That get that familiar skills of the SQL language itself. We've got search. We've got the eventing service for streaming and doing change data capture like capabilities. We've got the analytics service, and of course, full security and mobility built into the Couchbase environment. So here's really a summary of what went into Capella and is making it, what if you were to ask me, what was it that you guys did to make Capella so much faster even than its predecessor versions that we've released earlier? Well, number one is we'll demonstrate, and I'll talk about in a minute, the scalable transaction support that we put into the database. So we now have ACID transactions in the SQL query language inside of Capella, and that's going to make it so that if you have a transactional application, you'll know exactly how that environment is going to scale and how your app is going to behave. And you'll see in demonstrations later on in the conference that we're demonstrating transactional applications all over the place. We have what we call collection level processing now. And what this does is, rather than process all of our data, our queries, our indexing at the bucket level, we've now reduced that to the collection level. And the collection is a collection of documents that are interrelated to each other, or categorically related to each other. And what this has created is queries will run much faster when it's operating against a collection. Indexes are significantly faster because their indexes are not nearly as large as they used to be. This parallel index build, right? You can build 100 or 1,000 indexes all at once, and the time it's going to take is only the amount of time as the largest index that you're building. We've actually introduced a number of a new consistency library that manages the cluster metadata. And what's interesting about this is that's created an opportunity for us to make failover faster, or make data rebalancing significantly faster for auto scaling your environment. And Capella takes advantage of all of these. So we've also, scopes and collections help in areas of multi-tenancy. And then we've done some things inside the cloud environment itself to better utilize the infrastructure resources that we have available to ourselves. So the hosted version of Capella has some really tight tuning of the Capella infrastructure underneath. It doesn't consume as much CPU nor memory, yet is still going to deliver really, really amazing price performance. And you'll see what I'm talking about in a second. So as I mentioned earlier, we put transactions, ACID transactions, inside of Nickel. And what this is demonstrating, a typical TPCC benchmark of Couchbase 7 that, of course, remember, we released the Couchbase Server 7 in July. So we have these transactional queries and different consistency settings that we're looking at the queries as we run them. And you can see that if I want unbounded queries that where I'm a little looser on the consistency level, it favors performance, and they're going to be faster. So my first and my third operations here are those. And then if we run under request plus kind of setting, then the documents, we do respect transactionality and consistency for everything. So it favors consistency over that performance. But you can see even the hit that we're taking here is not that large. And the nice thing about this is very, very linear kinds of scaling. So you can set expectations of how the application is going to behave in the future based on information like this. But my real proof point, or real point that we're trying to lay out here, is make you recognize that the settings, that the scaling itself is very consistent. Now, I mentioned that parallel index build thing, and I'm really kind of very hot on that. So between version 6 and version 7 of Couchbase Server, you can see the initial indexing build times that's of the Plasma engine and/or the MOI engine, and each of these, the red lines are the 7 numbers, and you can see that they're significantly better than what they would be if I was building 1,000 indexes at a time in each of these cases. So really dramatic improvement in indexing times, whether it's initial build or the incremental build. You can see they're both super impressive, and you can expect to see that inside of Capella as well. So I mentioned earlier this notion of collection level processing, and our global secondary indexes, what's cool about them now is that they're processed at the collection level. And what we end up doing is, we've improved index scan latency because everything's smaller. So your indexes are going to run, retrieve data much more quickly. And it leads to ultimately better data ingestion, better replication, better migration. All of these are affected by these tighter and smaller indexes. And it still supports the hierarchical capabilities of bucket scope collection kinds of structures, just like a regular schema does. But what's also cool about this is when we replicate data or when we shard the database, everything is sharded at the collection level. So your related documents are all traveling with each other, and their indexes travel with them as well. So if they're moving from node to node as you grow a cluster or you shrink it, this capability is driving behind what's driving that kind of performance. All right, so next I want to talk about, one of my favorite topics in that me and my team end up sponsoring these kinds of activities quite a bit, is I want to go over some of the results of a performance evaluation of a variety of document-oriented databases. And what we'll talk about is Couchbase, Capella, and probably its three closest competitors. And we've commissioned Altoros to be a third-party validator of these activities, and they run these very independently themselves. But these are the results. So we set up typically 4 different, say runs or workloads that we look at, and the workloads themselves are, they're labeled. The first 2 are the standard Yahoo cloud serving benchmark workloads. There's Workload A, which has a balance of half reads and half updates to the data that you're managing. And then there's Workload E, which is a lot of reads and only a few writes. So one might be Workload E might be a good example of that is a shopping cart activity or browsing for products or flights or planning travel. You're looking for things a lot, but you may not. The amount of transactionality or updating you're doing is low. The pagination workload is akin to it's a filter of information, and then set with a limit. It's almost like creating a leaderboard in a game. So you want to have that be very, very responsive as you're building and updating information, like multiplayer scoring systems. And then finally, the join workload is we're joining orders to products to orders. And then it's got grouping and aggregation built into that workload. And the reason why we're highlighting this is because it really does accentuate the fact that Couchbase supports joins and supports all of the familiar SQL constructs that you're used to. And we just happen to do so, on the document data store. So the client tool that we're using is spun up inside of AWS. It runs 20 in sets of 25 to threads, and we run those anywhere from 25 to 175 per node. We'll run these things from 100 to 700 threads against any given database as we're scaling this thing up. But that's just kind of the background of how we're generating the load on the databases, or Altoros is generating the load. Anyway, so the configurations that we're going to evaluate, we have a 6-node cluster and 50 million records. And then when we jump up, we added 50% resource to the environment, but also doubled the amount of records that we're handling in that 9-node cluster. So you might see some of these. Some of the information look like it looks like the databases are getting loaded even more so on that 9-node cluster. Well, it's true, right? Because we're running twice the amount of data through an environment that's only 50% larger. And then we double that again in both cases to run an 18-node cluster with 200 million records set up in it. And the players that we've done is we're evaluating Couchbase Capella, we're evaluating Atlas, DynamoDB, and CosmosDB. And in many cases, in a couple of the cases, especially with the systems in blue here, are that it's difficult to identify or create actual cluster kinds of environments because they don't expose that for us. So what we did is we picked the dollar amounts, the highest dollar amount that we could apply to those services, and spun them up to see how much work they could, that dollar amount could do. So that's what the case was with DynamoDB, as was the CosmosDB environment. So, and you'll see in a minute, what I'm really going for is a dollar-based or a monetary-based metric for TCO, and that's why we're balancing all the stuff about what the spend is, your monthly costs are for any one of these kinds of environments. So most of our graphics look like this. This is what Altoros produced and laid out. So this is what the workload A looks like. The red is Couchbase, the green is Mongo, the blue is Dynamo in this case. And you can see even the latency of Couchbase versus these other databases is also pretty incredible. But Couchbase scaling really nice, nice and linearly as we're growing from 6 to 9 to 18. And at the same time, the other databases are growing linearly too, right? The line is nice and stable, but the throughput that they're getting, the operations per second, is just significantly lower. So when I built out our cost of operations formula, I had a number of variables that were at play here. There's the monthly cost of operations that I just talked about a minute ago, and from that tells me what I'm what I'm committing to spend on any one of these services, in any one of these configuration sizes. So then I need to actually match the that money to what the workload was that was running maximum, max workload that I'm getting as a measure of operations per second. So what I need to do is actually create like an operations per month kind of metric, so I can match up my monthly cost to that metric. So that's what I did. My third line here is just how many seconds are there in a month. It turns out there's 2.5 million, just over, and then we can start to dial in and identify particular values to this. So when I first introduced this cost of operations formula, the first metric we built was this millions of operations per dollar. So that would give you a throughput number for every buck that you were spending, and so really easy to understand. And in that case, the higher is always better. And then we would do a what's the delta of that the advantage in percent of Couchbase over either of these any of the other vendors. And then my latest cost of operation is actually the reverse of this, which what's the cost for 1 billion operations to run in that month time, in that month time frame. So we'll take our monthly cost, we'll divide it by the operations per second, and times the seconds per month, and then divide that by 1 billion, right? So it gets a pretty significant number here. So, and the cool thing is, all of these databases, they're able to handle that kind of volume pretty easily. So you'll notice there's quick observations. Couchbase in some cases runs in the tens, the $10 or the tens of per billion. Mongo and Dynamo oftentimes get up into the hundreds of billions, so that's a pretty significant uptick. And Cosmos gets even higher as we look out, which is not unlike what we've heard from customers. So the formula looks like this. So if I was doing that 6-node YCSB workload A readout, here's what my values are. Like I said, Couchbase came in at $48 cost per billion. Mongo comes in at 123. Dynamo comes in at just about 75% higher than ours, and then the CosmosDB one comes in almost 2.5 times what the MongoDB one is. So of all these 4 runs, this is what the data looks like for Mongo and Dynamo. These tests were run simultaneously, and you can see how everything plays out, including the advantages of each particular database. When we get to that pagination workload and the join workload, we hit some anomalies in that the pagination workload they couldn't do in Dynamo, and Dynamo doesn't have any kind of form for joining documents to each other. So we opted not to run those tests there. But you can see that, Couchbase comes out pretty nicely in all of these, although not perfectly. Like, the Workload E, Mongo, when it's in its small cluster size, is competitive, certainly. And then you can see what it looks like when we compare Capella to CosmosDB. The numbers are much more both impressive and apparent, right? The performance differences here. And this is one of our earliest sets of activities that we did in just trying to understand what expectations could we set with customers regarding running in different clouds and running Capella in different configurations. But this one, this is all pretty staggering to me. So let's look at then what this means in terms of real cost per billion operations, right? And when I look at any one of these tests, right? So this is the original YCSB test, the Workload A, Capella versus these other three. Capella's on the left. Lower is better here. So about $50 per billion operations. Pretty good price point for that 6 node. It drops down to somewhere in the about $38 on the 9 node, and then stays pretty consistent in that $45-ish range per billion in the cluster for the 18 node system. And you can see that all three of these other vendors, their numbers are pretty consistent, but certainly cost is more as we're running these. So that's Workload A. Workload E, same kind of thing, just more dramatic in terms of what the cost per billion operations really turns out to be. And Cosmos ends up spiking this thing quite a bit in terms of its run. But Capella, again, very, very consistent and eking out more lower cost per billion than each of these guys. And then looking at the pagination workload, we've eliminated Dynamo in this, and you can still see how Capella itself stays on kind of on track as it scales. It still comes in lower than each of the other vendors, and it's still very dramatic. So anywhere between 2 and 20 times faster, and are capable of doing more work per dollar. Or as I keep saying, right, that your cost of operations per billion operations for these different workloads. So what does this really mean in terms of that TCO promise that we've been discussing with Capella? Right, it's an incredible high performance database, right? That's number one. It's got everything that Couchbase 7 has inside of it. So those early tweaks that I just mentioned are included in the Capella hosted version that you might start a free trial on right now. Anywhere from 2 to 12 times faster node for node on these kind of environments, and we're coming out with very, very competitive pricing options for the different tiering and packaging structures with Capella. So your basic environment, which includes the query, indexing, and data service inside of the database, very, very competitive to the other guys. Developer Pro is the full complement of Couchbase services inside of the database, but you just have a slightly lighter support contract or support service level agreement that you're getting with Couchbase. And then enterprises for full production, 24/7 support, those kind of things. Unfortunately, Atlas fell short on latency times, right? That was pretty apparent. Scaling out, was also very apparent, and has limited support for those SQL constructs that that I was highlighting, including that join support. No contest in terms of what Couchbase does in that regard or not. And then in DynamoDB, you did require data model changes to restructure the documents if we were going to do the pagination workload or the join workload. And the other challenge, of course, is both Dynamo and Cosmos don't show you what what kind of cluster configuration is living underneath their environment. So you can only they operate as a black box, so you can only feed it more coins to make it go faster and more scalable. And that's certainly what was found out here. So when we look at your ultimate buying options with Couchbase Capella, the capabilities here, basic would start at anywhere from about 32 cents an hour per node. I think is a very, very competitive price point here. It's available as on demand, so you turn it on, and that's when your charge kicks in. You turn it off, and that's when it stops. Or an ongoing configuration. And Developer Pro, as I mentioned, the only difference between Developer Pro and Enterprise in terms of features is that it's the technical support and SLAs that are available to you is what's different. Otherwise, it's the exact same deployment of Couchbase and inside of Capella. Just your technical support is available 8x5, and your enterprise support is 24/7. But we'll get back to you in half an hour. So really, for those quick critical workloads, enterprise is certainly the way to go. So when we look at that, what's really driving down total cost of ownership here, the things like the advantage of having just a database as a service, right? You get to take the service as an operating expense rather than a capital expense. You can expand and add cluster nodes as you need. You enjoy it as a managed product, so you don't need to know all of the ins and outs of managing a high performance database. You can rely on folks like us to do that. In a single platform, delivering, reducing your overall license and hardware costs, much easier to learn, and leverages all your existing skill sets, as we mentioned before. And then finally, the services themselves, because we're taking charge of the entire environment, we've really optimized how well it's going to perform underneath. So we know exactly the tricks that we would apply to our own deployment, and that's what we've done for Capella in its hosted form. So it's really easy to scale up and down, in and out as necessary. And like you just saw a moment ago, the price points of running Couchbase Capella are really compelling. And we hear that from customers all the time, right? So the customers that we've interviewed, they talk about their goal of reducing costs and enjoying a lower operating cost if they if they make a switch from one environment to the other. They've seen 13% have seen more than 100% improvement, and then we kind of go down from there. We see at least almost 60% of customers see anywhere between 50% TCO or higher returns there. And really incredible that 76% of customers see at least 25% improvement. So overall, it's going to be worthwhile to at least investigate the performance capabilities of Capella here. So as we start to wind down, remember, it's as easy as SQL. This is exactly what you know. And your development teams will recognize it and be very comfortable in Capella. You start it up in about 2 minutes or less. You can develop with agility across any of your use cases. That breadth of capabilities, the data access services that we offer, give you that optionality that we often talk about to build and make future-proof the kinds of applications that you're trying to create. And then finally, it's blazing fast. And I think you're going to certainly see that and help you help deliver that low total cost of ownership as you live with it in the future. So thank you very much, everyone, for your attention today. If you've got any additional questions or any follow-up, feel free to contact me. You can connect with me on LinkedIn. You can send me an email at jeff.morris@couchbase. And I really appreciate your time today.